Hello, in this video I'm going to interview Thorsten Wiegand. Thorsten already gave you a short overview of point pattern analysis. Now we are going to talk a bit about his personal career and science in general. Hello Thorsten.
Hi.
So what would you say were like the most surprising results you ever found in your research so far?
Well, I think that's a quite difficult question, but if I think it right, maybe it actually happened only recently this year. So the task I was working on was I want to try to prove that spatial patterns actually can promote stability in communities such as tropical forests. So I was looking at spatial patterns like aggregation and segregation and things like this. And I actually managed to show theoretically that this should be true. But then, of course, I implemented this as a spatially explicit simulation model, and it didn't work. So I did lots of testings of my program, but community dynamics were always unstable, with some species becoming extinct. Yeah, and then finally, I changed the way how new small trees, or that means that they were recruits, how they were placed in space. So of course I followed the usual approach of placing them with a dispersal kernel around adult trees. So this is what all people did before. No? And this can generate observed levels of aggregation, and it leads to unstable dynamics. But then I did only one very small change in the program. So I changed the way how the new trees were spatially related to the adult trees. So I disassociated the recruits spatially from the adults, and then the simulations immediately got stabilized. And this was a really big surprise, especially because this way of distributing recruits is closely related to mechanisms of animal seed dispersal that can create aggregation independently on a seed dispersal kernel. Yeah, so in this way I found a type of overlooked mechanism that can stabilize community dynamics. On the one hand, in agreement with previous research, the spatial structure does not really stabilize if recruits are distributed with a kernel around adult trees. So previous research was right. But then, however, I found if I change this way, then spatial structure is able to generate stability. And I think this is a quite important result, especially because it contradicts one of the biggest long-lasting paradigms in ecology, so that you need that ecologically identical species cannot coexist. And with help of space in the right way, it actually can work.
So I agree, these are very interesting results and a different way to think about what we did in the past. So did those results lead to any other research questions?
Yeah, so what I learned from this discovery is basically that one should not always follow the common conventions of doing things. Now one should try new ways and follow their own intuition and try to do non-standard approaches. Of course, this unexpected result now will lead to new research questions. So, for example, in the forthcoming research, I will look in more detail into the mechanisms that generate spatial patterns in tropical forests. And then, of course, especially look at the effect of animal seed dispersal. So in many of these forests, you have monkeys or big birds that disperse seeds and then concentrate seeds in certain areas. And this can create aggregation independent on the location of the adult trees.
So we talk a lot about space here in these videos, and you already mentioned tropical forests. So what is, geographically speaking, the region you work the most in? And then what is, ecologically speaking, your motivation to do so?
Yeah, so that means if one looks at the point pattern of my research projects, there is, in a way, a positive association to Mediterranean countries, so to sunshine, beach, and wine. But the strongest aggregation of my research activities is in Spain. And at some stage of my career, I had even 5 Spanish-speaking postdocs at the same time in my lab. Yeah, but this aggregation was not initially caused by ecological questions, but this was simply happened because after my PhD, I learned Spanish, and then 2 years later, I had a bicycle trip in Spain, and then it was raining in Oviedo. This is in northern Spain, and then I could not go on. And then I went to youth hostel, and then for whatever reasons, they put me together with a young PhD student. And this PhD student was studying the production of seeds in a very nice forest in northern Spain. And this seed production was important for brown bears. And then we were talking, then he invited me to see his study site, and then I was there, and I found this very interesting. And then I convinced my boss that I also could do some modeling on extinction question of brown bears. So this was my first contact with Spain, and then I discovered there are really extremely good scientists in Spain. And then, like a snowball effect, we got more and more contacts to Spain and to other Spanish-speaking countries like Argentina and also Chile. Yeah, so in this way, of course, then I had lots of things to do, and then the first generation of collaboration people, they sent their PhD students to me, and then the next, second, third generation, and then it built up, and I felt very happy. And
yeah, that's a nice story. So I think you would agree that most of your work is rather theoretical, but I'm sure there are also applied applications of your research.
Yeah, so even the first work I did in Spain was quite applied because this was related to the extinction problem of brown bears. And I did this in the early 90s, and at this time there was a dramatic decline in the population of brown bears in northern Spain. And the question was if this population is still viable or it's close to extinction, and what management actions you can do to save this population. And then my task as a modeler was to put together all the fragmented pieces of information, place them into the framework of a simulation model. Yeah, and this allowed us then to find the most sensitive parameters of the population, to reconstruct more or less the number of individuals which are there, determine something like the minimal viable population for the brown bears and things like this. And then later on, I did also similar work with the spatially explicit simulations of brown bears. There was an invasion from Slovenia into Austria, and I supervised work on the viability of lynx in Spain and Germany. So this were always work with this carnivore species which are extremely, say, applied and to support, say, management.
Okay, so we have seen you worked in many different places in the world or on the world, but you're mostly based in Germany. So what do you think, how did science change over time in Germany, or maybe even on a global scale? Was it maybe better the old days?
Well, I don't know, you know, früher war mehr Lametta. So it means in earlier times everything was better, maybe in your memory. But it means, if I think it right, there were more or less 3 really important changes. And the first one is that now science become much more international and collaborative. So if I think back on the first meetings I attended on the Ecological Society in Germany, they were all in German. But now they are by default all in English. And this change was done more or less in the early 2000s. And caused at this time lots of protests of some people. But now it's standard. Nobody will dispute this. No, this is one big change. So it's much more international. Then another big change, of course, happened in the ecology in Germany with respect to modeling. So in my first conferences, end of the 80s, we were extremely exotic. And with this rubber boots ecologist fraction, they didn't like us at all. They were very skeptical about our research, and they were not able to understand equations and other things. And this has now changed completely. So there are lots of people, scientists, and also professorships in Germany that use modeling, that use simulation modeling, that use point pattern analysis, that use analytical modeling and other things. And if you go to meetings, if you look at papers, so modeling is a really important part of the whole story. So this changed really a lot. Yeah, and then finally, there's also a notable shift in research interest to more spatially explicit questions. And also much more spatial questions and methods are developed. So if one looks, there are more spatially explicit simulation models. The whole issue of species distribution models, in a way, is also spatial modeling. And there's much more research also on spatial point pattern analysis.
Okay, so we've seen a lot of change in the last years. So do you think your latest paper would have been possible, let's say, in the 1990s?
Well, not sure, because lots of the concepts were not ready. So maybe nobody would understand the paper then. But on the other hand, lots of my old papers, even some from the 90s, I think I could equally publish now. Because in some respects there was no change, and in certain things not much progress was going on. Maybe I was at this time far ahead of the time or whatever, but yeah.
Okay, and maybe related to that, maybe not. What was the biggest challenge in your career so far, and how did you deal with that?
Yeah, I always had a really smooth career, and I could do the things I like to do. So that means I had not a really big negative challenge, but I had a positive challenge. And this happened in one period about 10 years ago, when I had about five Spanish-speaking postdocs at my lab. And then at the same time, I got a big ERC advanced grant that gave me another big research group, about 5, 6 or 7 postdocs, again for 5 to 6 years. And in this project, we worked also on spatial point pattern analysis, simulation modeling, and this dedicated to tropical forests. Yeah, this was a big logistic challenge, to have enough time for all the people to think on how to push the research questions, the concepts, and to keep everybody busy with reasonable things. Yeah, at the end, I managed this because I worked together with one colleague, with Andreas Huth, in this big project, and then we managed the project basically together, and then we could accomplish it quite nicely.
Okay, so that was a good challenge, actually.
Yes.
So we talked a lot about the past, so maybe now let's talk about the future, because, for example, me as a young modeler, I'm excited about the future. So what do you foresee for the future?
Yeah, difficult question. Predictions are always difficult, especially if they concern the future. Yeah, but it means if I think it, I guess there will be much more spatial data available, for example, from satellites and from drones. And there will be much more attempts and enthusiasm to use machine learning and big data. This is also a thing we know in our research center and in the Helmholtz Center. There are lots of programs and initiatives to bring people to use big data science. But on the other hand, I think this is in a way black box research. You put all the big data together into a black box and then you see what's coming out. So you don't learn anything. So it means one needs lots of theory, to find the best way to take advantage of the data. And modeler and we as modeler, we are the people that can do this. So I think in this way we have a good future if we manage actually to assist people working with the big data. And if we also think about how to connect theory with this big data.
Okay, I'm glad to hear that you still left some research question for us young people that we can look at the future. So yeah, thank you very much for participating in that project, and all the best for your future personally. Thank you.
Yeah, thank you, Max, for inviting me. It was a big pleasure to participate in this very nice project.
Dankeschön. Gut.
Bitteschön.